quadratics, we're going to remember how to factor quadratics. A quadratic is anything that's something squared, right? So if you want to factor it, the two main methods we have are diamond method, that's for trinomials, and difference of squares, that's for binomials. Difference of squares. The first one we're going to factor, so we're going to do the diamond method because it's a trinomial. Do your diamond. On the top of your diamond is your A times your C value, so -10. On the bottom is your B value, -1. The sides, these numbers have to multiply to be the top number, add to be the bottom. Numbers that multiply to be -10 and add to be -9 or -1. That's creating the diamond. You then use the diamond to actually turn your trinomial into your two binomials. When your trinomial has an A value, the A value has to be the first in both sides. So in this case, you put 2x and 2x. The sides of the diamond, you then put in the two space in the brackets. That's how you should be factoring using diamond method. If there's an A value, it means you had a 2 and a 2. We know that doesn't make sense. Because when you multiply these things back together, 2x times 2x doesn't create 2x squared. It would create 4x squared. So what's the last thing you have to do once you put those things into their brackets? Divide one of them by 2. This one divides perfectly by 2. So the x minus 5, and the other one stays the same as 2x plus 1. That's the solution. Right, that's diamond method factoring. You guys should be getting really good at that by now. Difference of squares factoring is even easier. The first thing is to remember to always do a GCF if you can. You can't GCF this one, but always check, right? Because sometimes you forget, and that makes a big difference. The next thing is to make sure you actually have a difference of squares. To have a difference of squares, you need a subtraction sign, which we have. You also need to have all perfect squares, perfect square numbers, and perfect square variables, which you have. Once you confirm that, you can square root both things. That gives you 9x minus 7y. With difference of squares, when you factor, you should always get two binomials. This is only one binomial. What's the second binomial going to be? Exact same thing, different sign. So the first one has a negative, the second one has a positive. And if you flip-flop, it doesn't matter. That's factoring a difference of squares. That's Math 10 stuff. The Math 20-1 stuff looks more like this, where it's a little bit more challenging. And the reason it's a little bit more challenging is it doesn't immediately look like a difference of squares. It looks like a crazy equation, right, where you need to be like multiplying things and factoring, and foiling and stuff like that. When in reality, this is a difference of squares. This is a perfect square number, 9. And then you have a perfect square binomial. You have a binomial squared. Then you have a perfect square number, and another perfect square binomial. If we just replace these two things with m and n, imagine what it would look like. It would just be 9m squared minus 4n squared. And now that looks like a difference of squares, right? It looks like something we've done before. When we get a question and it says to factor, we have to find a way to make hard questions look easy. We do that by replacing things. When you replace them, you should, somewhere on your paper, write what you replaced. So m equals x minus 3, n equals x plus 4. Somewhere on your paper, you should do that. The reason you do that replacement is to create a situation in the factor. I can difference of squares that. squares, just square rooting everything. One's negative, one's positive. Now my answer right now is in terms of m's and n's. My question was in terms of x's. So that means I need to substitute these things back into their original spot. And that's going to make a really big, messy equation. What's been helping some people is using different types of brackets. So when we make this substitution, we're going to use curly brackets. But these binomial brackets, I'm going to make these square brackets. And that might help. They mean the exact same thing, but they just help organize your work a little bit and help understand what you should be multiplying and what you shouldn't be multiplying. You see I use big square brackets around the outside. The reason I'm doing that is I want to only simplify things inside each set of square brackets. This helps people recognize that the only multiplication I need to do is things inside the square brackets. I don't need to multiply the two square brackets together. This means in the first set of square brackets, if I did all my multiplication, I'm going to end up with 3x minus 9, meaning 2x minus 2. The second set of square brackets, so multiplying 3x minus 9 plus 2x plus 2. Inside the square set of brackets, I'm still simplifying if I can. I can collect like terms. So my final answer would be x minus 11. And then 5x. If you use curly brackets in your answers to the square brackets, that's perfect. As long as there's a set of brackets there, you're good. The only reason I'm using square ones is to show what I do want to multiply, what I don't want to multiply. I don't want to multiply the square brackets together. Do we have any questions about that factory? Jacked up factory. Just want to shop for it. Yes.
When you have the conjugate there, like the negative and the positive, is that just like a way of doing, like since you added your own squares, it's the same thing as doing like 3n minus 2n with the little plus and minus up front, or is that different?
That's different. Yeah. The only reason it turns into, like in conjugate, that's a good word, right? Conjugate means one negative, one positive, right? The reason that with factor you do get conjugates is that if you multiply these together, you need the middle terms to cancel out, which would create a binomial instead of a trinomial, which is why it ends up 20. You start with a binomial. But it doesn't have anything to do with the plus minuses. All right. Jacked up factoring a trinomial. This, again, doesn't really look like a trinomial, but it is. This is your first term, this is your second term, and this is your third term. The difference is that in each term, there's another little thing, and that's what throws people off. That's what makes this question so hard. You do not want to expand this. Instead, you want to make a hard question easy. To make a hard question easy, you take those binomials, x plus 2, and you change it to be a different letter. And this time I'm going to choose y. You can choose any letter you want as long as it's not x in your case. That means my replacement then looks like this. 3y squared plus 4y minus 7. That's a trinomial we know how to factor, and we know how to factor quickly. We factor that with a diamond method. Negative 21 and 4. Then be 7 and negative 3. That gives me 3y minus 3. 3y plus 7. Right, sides of the brackets are the second things in the binomials. The first term in each binomial is 3y and 3y. You can't have 3y in both binomials. So you've got to get rid of one of them. Get rid of the one that can divide by 3. That one can divide by 3. So I now have y minus 1, 3y plus 7. And that's good, and it would be about half a mark on a written test. So what's my final stop? Replacing it back, substituting it back. It started as x's, it needs to end as x's. Right now my answer is in terms of y, and that doesn't work for me. So I need to change those y's back into x's. Again, if you want to use square brackets for the brackets that were already there, and then use round brackets for your new substitution, that's fine. That's helping some people, so keep doing that. So we look like this, x plus 2, minus 1, 3 times x plus 2, plus 7. Again, the only reason I'm switching to square brackets is to show you that you only want to multiply things inside the square brackets. That means this 3 needs to multiply in. Is there anything that actually has to multiply in the first step? No, there's nothing in front of this, right? There's nothing in this space. So that means these brackets that are round are pretty much irrelevant in the first set of brackets. I can get rid of them, so now I have x plus 2 minus 1, x plus 6 plus 7. And then within each set of square brackets, I can collect any like terms that I have. It becomes x plus 1, and it becomes 3x plus 6. Any questions on how I jacked up that? Alright. When you see a question that says factor, and it's in your test, it does not mean solve. Remember, that's two very different things. Solving is when your question has an equal sign. Factoring is if there's no equal sign and they just want to see the skill of factoring. A lot of people end up doing a question like this and then giving me an answer somehow and saying x equals -1. There was never an equal sign in the original question, therefore there should be no equal sign in the final question, the final answer. It's kind of the best way to look at it. If it says factor, just factor. Don't worry about doing anything else. Alright. Quadratics. So in this unit, you remember all those things we were factoring and all that mumbo jumbo we were doing. At the end of the day, it was creating something called a parabola. A parabola is this shape right here. In the question given to us, we only have a picture. We do not have an actual quadratic function here. So we're going to try to create a quadratic equation that would create that one right there. The reason I know that is that's part of this. Okay? We'll go through in order, and we'll do A, B, C, D, E, and F. But when eventually we're going to have to create an equation. So, first part says, where's the vertex? What's the vertex again? What's that mean? Yeah, it's the highest or lowest point that you have. In this case, it would be a lowest point. It would be at 1, -3. And if this was a test, they would have put a dot on the vertex, meaning that you know it's for sure right at that intersection. It's not a little bit off, it's exactly there. So they would put a dot. We also call that a minimum. The reason it's called a minimum is it's a lowest point. If it had been a highest point, we would have called it a maximum, right? Just different terminology. So the vertex is at 1, -3. All right, domain and range. Domain is asking you for your total possible x values. How far left and how far right does this graph go? Yeah, and we know that it's always just XER unless it's the word problem, because quadratics go forever to the left and forever to the right. The range. The range is a little bit trickier. The range is asking you possible y values. How high can it go? How low can it go? In this question, we have a low point, a minimum. So that means y will always be greater than or equal to whatever that low point is. In this case, the low point is at -3. So the range would be y is greater than or equal to -3. And you could throw YER on the end of it just to say any number greater than -3. All right, direction of the opening. Direction of the opening means exactly what it means, direction of the opening. I don't think I can break that word down. So it's like, which way is it facing? In this case, it's going upwards. So you would say direction of the opening is up. That's it, nice and simple. It is a minimum, but that's not what it's asking. Yeah, it would have to say either up or down. Axis of symmetry. The axis of symmetry is a vertical line that cuts a graph perfectly in half. In this case, that line would be right here. That green dotted line cuts this graph perfectly in half, so if I folded it over, it would go right on top of itself. The axis of symmetry is always going to be x equals something. That something is always the x value of your vertex. So in this case, it's x equals 1. All right, equation of the function. This is going to be the fun part. So we had to somehow create an equation that would represent this function. Anytime you're creating an equation, you need to choose the proper form to create it in. There's 2 forms to choose from when it comes to creating. You could do factored form or vertex form. If you're doing factored form, it's because you know your x-intercepts. If you're doing vertex form, it's because you know your vertex. So which one would be best for this situation? Vertex form, right? I have a vertex given to me. The vertex form is this. That is vertex form. It will be given to you on a test. It will not say it's vertex form. Okay, so your formula sheet will just have this form on it. It won't say this is vertex form. It'll just have this form on it. This is vertex form because in your vertex, the x value is p, the y value is q. So that means I have y equals a, x minus p is 1, squared plus q negative. So one of those brackets holds that group. I took my P and my Q, I substituted them into my vertex. Now what this did, so I simplified it. So I just wrote it kind of properly without the brackets and without the plus minus thing. What that did was this created a quadratic with a vertex at -1 and -3. What it did not do is create the quadratic that's in the picture. The reason it didn't create the quadratic in the picture is the quadratic in the picture has to have a specific A value. And we don't know what that A value is yet. To calculate that A value, you need to find another point on your graph. In this case, they would have put a dot right there. The point there that they're giving you. That point is 0, -1. What they're doing by giving you a second point is they're giving you an X and a Y value to substitute into your equation. And that'll allow you to have one equation with one variable, which is A. Which means then you can solve what A must be. So the way that would look, I would replace my Y and my X with what Y and X are. So I would have -1 equals A, and then 0 -1 squared minus. You notice now our equation has nothing left in it except an A and a bunch of numbers. That means you can isolate A. To isolate A, I first calculate what's inside the brackets. 0 -1 is -1. -1 squared using brackets is going to be +1. Now we ran into this problem a lot. And the problem is when we get to this point, people struggle to solve for A. The reason they struggled to solve for A is they thought that this 1 and this 3 could be added together. So they thought that 1 minus 3 means this is -2. But that 1 is a coefficient on that A. It's multiplying by it. You could write that as 1A, and then you'd never think that you need to add those numbers together, right? But it's the fact that it's written a little bit strange that it throws people off. That 1 is a coefficient. You cannot add those terms together. They're not like terms. Instead, what you need to do is you need to move the 3 to the other side. And that gives you 2 equals A. I mean, it equals A times 1. You need to write A times 1. So everything's times 1. The next biggest thing that people do is they just leave that as their answer. They think they're good. And it's not good. The question wasn't solve for A. The question was create an equation of this function for this graph. And you needed an A, a P, and a Q value to make that happen. You had a P and a Q value from your vertex. You had to calculate your A value. Now you write it all out in one beautiful equation. Your answer should be Y equals 2x minus 1 squared minus 3. That is the answer that would give you that exact quadratic. Yeah. Remember creating equations? Yeah. Does it seem easier this time around than it did a month ago? Usually the second time you see something, it looks a little bit like, oh yeah, I kind of know what's happening. Because you can guide yourself a little bit. All right, part F. Calculate the x and the y intercepts. Now there's a couple ways you could do that. Calculate the y intercept is really easy because they gave it to you. It's 0, -1. Okay? So that's a really easy way to calculate the y-intercept because it was right there on the graph. To calculate the x-intercepts, however, it's a little bit tricky. Now you could graph it and then find where the x-intercepts are, and that works. But if they ask for an exact value, then you have to do it by hand, algebraically. And there's something we know about x-intercepts, and I'm about to teach the great sense of it. Weird how that worked out. What do we know about all x-intercepts? That y equals 0. All x-intercepts have a y value of 0. So if you go back to your equation and you change y equals 0, you then will have a quadratic that you can solve. Solving a quadratic is finding the x-intercepts. It's the same thing. You can use any method you want. A lot of people sometimes get in the habit of knowing, oh, factor or whatever, box method, quadratic formula, they start expanding that thing and doing crazy things. If you have something in vertex form, it's like box methods already half done for you. Notice that you have a binomial square. That means if you can isolate the binomial by adding 3 to both sides, and then dividing both sides by 2, you'll get to a situation where all you need to do to get x by itself is square root both sides. And then you would have a single x all by itself. So from vertex form, to find the x-intercepts, you actually don't want to expand, you just want to isolate x. This is exactly where box method would have got you. It would have got you to the same situation. Factoring wouldn't have been possible in this one. So you would have had the box method. At this stage, I would square root both sides. When I square root both sides, I get a plus minus. I also get a square root on the bottom. If I have a square root on the bottom, what do I need to do in this equation? You're not allowed square roots on the bottom. We have to multiply by the square root, we have to rationalize, right? So that means we have to multiply by root 2, top and bottom, to give me plus or minus root 6 divided by 2 equals x minus 1. Notice that you only had to put the plus minus on the top. You didn't have to put it on the bottom. If you did a plus minus on the bottom as well, then you would just be canceling yourself out. The two negatives would just cancel out, be a positive every time. So you only need to do plus minus on the top. When you rationalize, you're only multiplying by what's on the bottom. We're then going to move the 1 over. So I have 1 plus or minus root 6 over 2 equals x. That's a funny way to write it. Why couldn't have I just written it as one big fraction right away? Why couldn't I have written it like this? 1 plus or minus root 2 over 6. Why couldn't I have done that? Because the denominator needs to be the same. Right? This 1 is a different denominator than this root 6. So you have to have the same denominator to be able to do something like that. You could do that by changing this to 2 over 2, and then you could write it as 2 plus or minus root 6 over 2. Now, realistically, you won't get a question like that, where it ends up with those skills, but it's good skills to understand and remember. We do adding and subtracting of different denominators in Unit 5, so we have a little bit of time before we have to worry about that. The big thing is remembering x-intercepts, your y value is 0, and then solve. You can just put in your calculator and get a decimal, and I'd be happy with this one. All right. There's a question here. It's a quadratic. It wants you to determine the vertex, the domain of the range, the direction of the opening, the axis symmetry, and the x and the y intercepts. It does not say what method you have to use. You could do it algebraically. That would suck. Or you could use your calculator. That'd be awesome. So, we're going to remember how to do all this using your calculator. We're going to start with the vertex. The first thing is we need to pull out our calculators and graph this. So on your calculator, you're going to press your y equals button in your top left-hand corner. You're going to make sure everything is cleared out of there, so you don't have any crazy equations in there. And you're going to type negative 3x squared minus 12x plus 5 into your calculator. Remember that this is negative 3. The negative button is down beside the decimal. So it's negative 3x squared minus 12x plus 5. So step 1, put in y. Step 2, make sure you have your standard window selected. If you've been doing crazy questions, you might have a crazy window in there. I always start with the standard window unless I'm given some sort of context. In this case, I'm not given any context. I'm just given general form. So I just make the standard window, which is negative 10 minimum, positive 10 maximum, scale 1. I then hit the graph button in the top right-hand corner. Should get a graph that looks like this. Somewhat. A little tighter to the origin. A little bit bigger gap at the top. Yeah. Anyway. This is nice, but it's missing the top of the graph. So I need to be able to see higher. Right now, the highest y value I could see was 10. I need a bigger one. So I'm going to go and change my y maximum, and I'm going to change it to be 20. If I do that, I then create this equation. It's the exact same quadratic I had in the first graph, it's just a different view of it. I've zoomed out a little bit so I can see a little bit higher. You have a good window when you can see x-intercepts, y-intercepts, and your vertex. That's when you have a good window. Alright, now let's actually calculate it. So to calculate your vertex, you're going to go second trace. So the second button right here, and then trace, which is the button beside graph. That'll bring you to a list of things. On that list of things, you're going to see number 3 and number 4 are minimum and maximum. Notice they don't say vertex. They want you to find a min or a max. So in our case, our vertex is a maximum. So you want to pick option 4, maximum. It then says left bound on the bottom of your screen. That means your calculator wants you to show it a point that's to the left of the maximum you're looking for. So you go left or right on your calculator until the little cursor it has is somewhere to the left of your maximum. You hit enter, it says right bound. And then you use your thing to show your graph or your calculator a spot that's right bound of your maximum. So right over, and I hit enter. What you should have on your calculator is 2 arrows. They should look something like this. They should be somewhere near the top of your screen. If you have a fancy calculator, it even draws a line for you. Did it give you a line? No? Nothing. Some people's did. Depends on the calculator. What that's doing is your calculator showing you where it's going to find the maximum. It's saying this is the maximum in between these 2 points. If your points don't make sense, or your maximum isn't between your two arrows, then your calculator's going to give you the wrong answer. So I went second trace max, I picked my left, I picked my right, my arrows matched up, I hit enter. My maximum is at negative 2, 17. Mine actually said negative 2.00000001. Round that. Did anybody get negative 1.9999999? Yeah, that's possible too. Round those things, right? So if it's something ridiculous, like a repeating number forever, round. All right, domain and range. We don't need our calculator for that. What's the domain always? X, P, R, and what's the word problem? What's our range going to be? Y is less than or equal to, because it's going to be below my maximum value. And the highest I ever went in my graph was at 17. So Y is less than or equal to 17. Direction of the opening. Down. Opening downwards. The axis of symmetry is that x equals 2, negative 2. The x value from your vertex. The x and y intercepts. We'll start with y-intercept. Because I'm not going to use my calculator for my y-intercept. How can I figure out my y-intercept without my calculator?
It's the C value.
It's the C value in general form. So that means it's at plus 5. And the x value is at 0 because all y-intercepts have an x value of 0. The x-intercept's a little bit trickier. A little bit tricky because we actually have to use our calculator. Our calculator doesn't use the term x-intercepts. Our calculator uses the term 0. To find the x-intercept in your calculator, you go second trace. And the second option should be 0. You click that, you hit enter, and it says left bound. Now, in your graph, you have 2 x-intercepts. One here and one here. Your calculator can only find one at a time. So when it says left bound, it wants you to go left, whichever one of these you want to find first. It doesn't matter which order you find them. So I'm going to do the one on the left first. So I'm going to come left of that thing. So I click my left arrow until I pass it, and I'm somewhere below it, down here, and I hit enter. It also creates a little bit of an arrow for me over here. I then says right bound, so I use the right arrow to go above my x-intercept, and I hit enter, and my arrow is now over here. The x-intercept you're looking for needs to be in between those arrows at the top of your calculator. If it isn't, then it's not going to find the one you're looking for. It's not the droid you're looking for. No, pardon? No, intersect is finding 2 lines that cross each other.
Oh, I always use intersect.
You graph the second line at y equals 0?
Yeah, yeah.
That's why. Yeah, you're finding where 2 lines cross each other. That's what you've been doing the whole time. Okay, so we use second trace 0. And we put it in between here, and we find that. If you put this second one all the way over here, you would have 2 x-intercepts in between your arrows. So you don't know which one your calculator is going to find. And if you did it again, it might find the other one. But I prefer to only give it one option, so it's always finding the one I know I want to find. And it just makes it easier and more organized. I hit enter, and it tells me that this one is at negative 4.38, 0. These other ones, I would do my second trace, and I would move it so that my arrows are more like that. Second trace 0, and I go all the way over there, and I hit enter, And my calculator died. So that's sweet. And the other intercept is going to be at 0.38, comma 0. Is that right?
Yeah.
How did I know that? Just for fun. Just for fun. My calculator died. I had no idea looking at my graph. It was at 0.38. How did I know it was going to be at 0.38? Because of the axis of symmetry. Right? If the axis of symmetry was at 2, then this x-intercept was 2.38 away this way. So the other one had to be 2.38 the other way. So you just add 2.38. So you could do it that way too. Whoa. I like the I'm psychic answer better. Whoever said that. That was good. That's good. Yeah, I wish. Books are cool too. I would definitely use my calculator on that, just for the record. It's just my calculator died. That's what happens when you use great value batteries. You need to use Duracell. But we're poor. All right. Solve the equation 6x squared minus 7x equals 3. In this class, you're always going to have two types of equations. You're going to have a linear equation or a quadratic equation. 90% of the time, it's a quadratic equation. If it's a linear equation, then that might even throw you off. You might not know how to do it. So, to solve a quadratic equation, we have to be in a certain type of form. What form do we have to be in? We have to be in general form. General form is ax squared plus bx plus c equals 0. Remember, that's always your first step. Get a quadratic into general form. In this case, we just subtract 3 from both sides. You give us 6x squared minus 7x minus 3 equals 0. Now, I'm in general form. It says to solve by factoring, so it's not giving us a choice to do the quad formula. It's not giving us a choice to complete the square. It does say we can graph it, but we're going to talk about graphing in a second. So we're going to factor it first. To solve by factoring, you need to do diamond method. You're going to look for things that multiply to be negative 18 and add to be negative 7. It's negative 9 and positive 2. So you have 6x minus 9, 6x plus 2 equals 0. You know you can't have a 6 in both of those. So you have to divide one of them by 6, but neither of them divides by 6. So you need to divide by two things that multiply by 6. In this case, 3 and 2 are the things you need to divide by. That's as hard as factoring gets when it comes to diamond method. We have to split up the a value into two chunks. This gives me 2x minus 3, 3x plus 1 equals 0. All right, I have factored it. Now I need to actually solve it. To solve it, we use the zero product property. So you need to ask yourself, what value of x would make each set of binomials equal 0? You can do it in your head. Some people are very strong at that. Or you can actually write this on a side piece of paper. I want 2x minus 3 equals 0. And then isolate for x. So add 3 to both sides. 2x equals 3. And then divide by 2 on both sides. So x equals 3 over 2 is one solution. It would make the first set of brackets equal 0. Then you'd ask yourself, what makes the second set of brackets equal 0? Make this guy equal 0. Well, it would be 3x plus 1 equals 0, minus 1 for both sides, 3x equals 1, and divide by 3. X equals negative 1 over 3 is the second expression. Okay, so these are just
whatever's next to the x, bring it again, just go on top.
yeah, and that works, and change the symbol, right? So, Yeah, and some people can, like I said, some people will be able to do it really quick, and some people just don't understand why that's happening or want to know why it's happening. This is why it works. Right? Because you're making it equal 0, which just means you're flipping and dividing. That's when you solve by factoring. I highly recommend you solve by factoring when you can. It's what you're best at. It sounds crazy. It's what you're best at. When you're solving a quadratic, what are you actually finding? Yeah, what is it, Tristan? You're finding the x-intercepts. When it says solve, that means find the x-intercepts. So if I wanted to solve this by graphing, what would I need to calculate? The x-intercepts. That's what I'd be looking for on my calculator, which we just practiced on the last slide. These would be the same answer. The x-intercepts would be 3 over 2 and negative 1 over 3. It would just give you decimal form, so it would be 1.5 and negative 0.33333. I recommend you factor when you can. All right. Solving using the quadratic formula or box method. Another way that they could state this without saying using quad formula or box method, they could say the same question, and they could just say exact solution. So if you see exact solution, that means you can't have a decimal, right? So it means you need to solve algebraically. Just know that it's probably not going to ask you to use a certain formula. It's not going to be that obvious. It's going to just say exact solution. And that should be your signal that you have to use one of those methods. All right. Solve using quad or box method. What's the first thing you always have to do when solving a quadratic? You've got to be in general form, right? You have to be. Always. No matter what method you're choosing, general form is what you have to be in. So I would rearrange that to be 2x squared plus 4x minus 7 equals 0. Now I'm not going to do quadratic formula because you're all good at quadratic formula. It's just plugging something right into that formula which is given to you. What we're not all the best at is using box method, and this is a hard box method question, so that's what we're going to do. So to do box method, you want to make sure that your a value is a perfect square number and that your b value is even. In this case, our a value is not a perfect square number. It's 2. So we need to turn it into a perfect square, either by dividing everything by 2 or multiplying everything by 2. We can't divide everything by 2 because we can't factor a 2 out of 7. But remember, if we could have factored a 2 out, that's the easiest way to do it, because then it turns into 1. Yeah?
So, you have like the 2-member box with, so that would be the one where we're trying to add this one to be done.
Okay. So to do this box method, I'm going to multiply everything by 2. Including the other side of the equation. It's just 0. Okay, so 0 times 2 is going to stay at 0. But we do it just for sake of understanding. We are balancing both sides of the equation. This gives me 4x squared plus 8x minus 14 equals 0. Now I have a perfect square a value and an even b value, so I can actually do my box. Box method is really just like an area diagram, but you're undoing that area diagram. We always know the first term comes from the first box. So what two values that are the same would create 4x? 2x and 2. Okay? 2 times 2 is 4, x times x is x squared. That's why you had to have a perfect square a value. Because you had numbers that are the same multiplied together. The next thing we know that the two corner boxes always add to be the middle term. 4x and 4x would add to be 8x. Now, the number one mistake people made on our last exam that we did was people would automatically put a 4 right there on the outside. That's incorrect, because 4 times 2x would have been 8x in the middle, not 4x. So you need to think of what number would go on the outside to create that 4x. So what number would it be? 2. The last box in your box method, you create. So in our case, 2 times 2 would give me 4. You'll notice that negative 14 is not positive 4. So the C value that I had in my quadratic is not the same C value I created in my box method. So I need to figure out what's the difference between negative 14 and 4. How much do I have to add to that negative 14 to make it 4? I need to add 18. And I add 18 to both sides. Now here's where people are getting thrown off. So if it is equal to y, not equal to 0, and you're trying to create a vertex form, because that's when you use box method, you're still asking yourself the same question. How can I get from C that I had to the C that I want? The only difference is if you're doing solving a question, it'll always be addition. If you're doing the vertex form, it's possible that the C value you have is actually bigger than the one you want. So then you would have had to subtract. But it's always asking yourself, how do I get from here to the box? So you're always going that direction. It's just it's possible that you have to subtract. Yeah, that's the difference. And that throws people off, because then they're like, whoa, why is it negative? And then it makes a big problem. The reason why it can't be negative when you're solving is remember that we're going to square root in a minute. And if you square rooted a negative on the other side, it wouldn't work. So that's why it's always addition when you're doing a question like this. Okay. You have successfully turned this quadratic into 2x plus 2 squared. That's the outsides of the boxes. And it's equal to 18. It used to be that quadratic equal to 0, but we had to add 18 to both sides, right? Now we can start solving this. So we can square root both sides. When you square root in this class, what symbol do you put in front of the square root sign? Perfect. So it's plus or minus root 8. And now you need to start isolating x. So I would have to subtract 2 from both sides. So I have 2x equals negative 2 plus or minus root 18. And then I would divide both sides by 2. So once you actually do the box method, create that quadratic into a binomial squared, that's when you do the math and the algebra to get x by itself. Square root both sides, move things over. That is like 3 out of 4 on a written question. What do we need to do to it still? We need to, I heard different terms for it, but we need to simplify that radical first. That's the biggest thing. Like that root 18 can be simplified, and this is why you guys actually got better at Unit 1 as we went along. Because you were simplifying radicals all the time during Unit 2 and 3. That root 18 needs to change to be 3 root 2 divided by 18 can be divided by 9, root 9 is you're left over with 2. Now at this point, mistakes that people make. they really want to divide everything by 2. They really want to divide this by 2, this by 2, and this by 2. Because there's 1 in all 3 of them. Like, that's awesome, I'll divide them all. The reason you can't do that is because the first 2 twos are coefficients. The other 2s are radicands. Radicands can only be divided by other radicands. So that doesn't work. The other thing people really want to do is at this stage, they want to divide both things by 2. Like really badly. They're like, there's a 2 there, divide by 2, and it works perfectly. The problem is, if you're dividing by 2, you have to divide all coefficients by 2. The coefficient of this radical is a 1. You would have to also divide that by 2 to be able to do that. So you can't. So this is your final answer. Because none of the coefficients, all of the coefficients can't be divided by the same number. Only some of them can be divided by 2. Yeah.
If that root 2, isn't it? Is that where you do the thing where it's like -2 plus 3 divided by 2, -2 minus 2 divided by 2?
Yeah, definitely. So if you had a question like this and it didn't have this radical, and you would actually solve it. Yeah. So you would have, you don't need to write this down. So if this was your answer, we break that into 2 situations. Situation 1 and situation 2. And then solve each of them. You solve them separately. Yeah. That's only if you have whole numbers. We don't do that if it's radicals. All right. We've solved a lot of radicals. Unit 2 was mainly just solving radicals. You are almost always looking for x-intercepts, right? That's just what it is. So you could graph a lot of things. You only need to solve by hand if it's telling you to get an exact value. That's when you're going to have to solve by hand. Or if it's a written question where it says solve using this method. Then you have to, and you have no choice. Yeah, let's do this word problem. Okay, word problems. This is most likely the type of question you'll get on a midterm or a final exam. It's also the type of question we got a lot of on our unit test. Right? And if you know how to do it, it's quick. If you don't know how to do it, you feel like a dummy because there's not enough info here. Right? Nope, the midterm's all calculator. Everything we write from now on, you'll have your calculator with you. Okay, so it'll never split on you. So you'll always have your calculator. All right. With a word problem, my strategy is to read it once, understand what the heck's going on in the world, read it again, and actually try to write information that matters. Okay? This says, Ted popped a baseball straight up with an initial velocity of 48 feet per second. The height in feet of the ball above the ground is modeled by the function, and so there's some guy named Ted, and he's playing baseball, and he hit the ball, and launches. Ted's got his baseball cap on. And he goes straight up. That is pretty good. Yeah, it's not very straight. Mine's a little bit off. You're right. So, straight up's just kind of more of a baseball term. They call it straight up if it goes really high instead of really long. But you're right. It does say straight up, and that technically means straight up. So that should probably change. That's all I got from the question the first time I'm reading it. The guy hit a ball. Right? The second time I read it, I try to actually draw some info out of it. So, Ted popped up a ball straight up with a velocity of 48 feet per second. I don't know what that means, but I'm going to say velocity equals 48. It's like, it seems important, it's math. It sounds like math. Some people use an S for speed, that works. The height, h feet. All right. H equals height. That's important. Anytime they're defining something for me, I definitely want to write it down. They're defining that h is height. of the ball above the ground is followed by this function, it should definitely say that t is in 0 seconds. Height in feet of the ball above the ground is modeled by the function after t seconds. They'll always define your variables. In your quadratic that they give you, this one right here, I'm going to write out again. I know that you wrote it out once. Do you see anything other than the letter H and T? Do we have a letter V in there? Do we have a letter S in there? Do we have anything in this quadratic that represents speed? We don't. This is a distraction, and you don't want to use it. Right? And the best way to understand it's a distraction is to understand what's in your equation. H and T, that's it. Height, time. That's the only two things we're working with. We don't work with speed at all. Now we can start answering questions. What is the maximum height the ball reached? Maximum means find your vertex. Anytime you read the words maximum or minimum, you're looking for a vertex. And if you look at our crappy picture we drew, that makes sense that I'm looking for this thing right here, my vertex. And they wanted the maximum height, so you're looking for your y value. Because height is my y, time is my x. So I would need to graph that thing in my calculator, which we're going to do together. And to graph that thing in my calculator, I'm going to hit y equals. I'm going to type that in my calculator. We have 3 plus 48x minus 16x squared. And I'm going to set a window that makes sense for this question. The reason I'm not just using my standard window is because this is a word problem. In word problems, usually, the standard window doesn't fit. Word problems also usually don't work very nicely for zoom fit, as some people found out on the unit test. Yeah. So zoom fit did not work because zoom fit sucks. So let's use logic to try to figure this thing out. We're going to set a window that we think is logical. And as long as we're close, we'll be able to ballpark it. Can I get that? Thanks. I'm pretty proud of myself. X minimum. Which variable was x in our equation? Time. And we're talking about time after I hit a ball. So what's the least amount of time after I hit a ball that could have passed? 0 seconds. So 0 is a very logical minimum time to have passed. Yep. Maximum time, x max. What's the most amount of time that seems reasonable for a ball to be in the air? Almost always the x minimum is 0. Yeah. And the y minimum is almost always 0 too. 15 seconds seems completely legitimate to me. That would be a long time in the air. But I mean, if I really hit that thing high up, it could go for a long time. So I'm going to put 15. That is a long time, right? But I mean, it's reasonable. I wouldn't put 500, right? And I wouldn't put 2. Right? That ball's going to be in the air for longer than 2 seconds, most likely. So I'm trying to think of a reasonable maximum time. Okay, can you guys stop packing up, please? Y minimum. What is our y variable? Your lowest height. What's the lowest amount of height you have? 0. What's a reasonable maximum height you have? 50. What's important is to know it's height in feet. Okay, so that's important. So it's height in kilometers. I wouldn't put 50. Height in feet. 50 feet up in the air. That's pretty high. Seems reasonable. I put 50. And then I graph the thing. We'll finish this section tomorrow.